let's talk about permutations today. So in 10.1, you talked about using different methods like a list or a tree diagram to find out how many outcomes there were for a particular something, to find a sample space. So for example, if you flipped two coins, you could have heads and then heads, or heads and then tails, or tails and then heads, and then heads, tails and then tails. Okay, this was my sample space. There were 4 outcomes possible when flipping 2 coins. So a permutation is an arrangement of objects, letters, numbers, anything, okay, in your sample space that are arranged in a particular order. So for example, if I have 2 letters M and A, MA and AM are not considered the same sample, okay? They're not considered the same event. So this is called a permutation. These would be considered 2 separate events. So find the permutations and the letters in the word fly. Well, I have the obvious, the first one, fly, F-L-Y. So keeping the F first, I can change the order of these 2 letters, F, Y, L. Even though they have the same letters, because the letters are arranged in a different order, they are their own independent events. So then I could have L go first. I could have L, F, Y, or L, Y, F. And then if I have Y go first, I can have FL or YLF. So there are a total of 6 different outcomes, independent, not the same. Yes, they're all using the same letters, but they're arranged in a different order. That is called permutations. Okay, so you can do the same thing with finding the 2-digit permutations you can make with the digits 1, 3, 7, and 9. Now, you can use a tree diagram, or you can just make a list. I'm going to do both really quickly. So I can have 1 and 3, 1 and 7, or 1 and 9. I can have 3 and 1, 3, 7, 3, and 9. Notice I'm doing these in numerical order. By doing them in numerical order, it's going to help me make sure that I don't skip any. So then if I start with 7, I can have 7, 1, 7, 3, 7, 9. If I start with 9, I could have 9, 1, 9, 3, and 9, 7, for a total of 12 outcomes. If I use a tree diagram, I'm going to have the number 1. So I can have a 3, I can have a 7, or I can have a 9, 4, 30. If I have a 3, I can have a 1, a 7, or a 9, for 31, 37, and 39. If I have a 7, I can have a 1, a 3, a 9, for 71, 73, and 79. And finally for the 9, I can have a 1, a 3, or a 7, for 91, 93, and 97. I still have 3, 6, 9, 12, so I still have a total of 12 outcomes. So it doesn't matter which way I make the list, come up with whichever way works for you. Just make sure that you are very methodical and not jumping and skipping all over the place, because you will miss some. Okay? That's it for permutations. If you would like to do 1 or 2 of the exercises at the bottom of page 481, that is totally fine just for some extra practice, but you don't have to. Okay?